Welcome to the new video seminary. Here is Dr. Hoffman. Subscribe and give me likes. Let's start now.
Consumer's utility. The theory of consumer behavior studies how a consumer spends his income so as to attain the highest satisfaction or utility. The Ordinalist school asserts that utility can be measured and quantified. It means it is possible to express utility that an individual derives from consuming a commodity in quantitative terms. The Ordinalist school asserts that utility can't be measured in quantitative terms. Rather, the consumer can compare the utility accruing from different commodities as a combination of them and rank them in accordance with the satisfaction each commodity or combination of commodities gives them. A number of economists have contributed to the indifference curve technique as it has evolved over the years, with the latest refinements attributed to Slutsky, 1919, or J.R. Hicks and R.G.D. Allen, 1934. Let's have just two goods. On x-axis, good 2, on y-axis good 1. Along the indifference curve, you can find the combinations of the two goods 1 and 2, which bring the same utility. For example, 10 pieces of good 1 and 1 piece of the good 2 bring the same utility as 3 pieces of the good 1 and 3 pieces of the good 2, or 1 piece of the good 1 and 15 pieces of the good 2. In addition, if the indifference curve is farther from the origin, it brings us more utility. The IC2 and IC3 curves represent a farther increasing utility. Some authors mark the IC just U, here IC3, therefore U3 for utility. We know that indifference curves are descending, do not intersect, and are convex. There are also any other indifference curves which we don't draw for simplification. We just choose IC 1, 2, and 3. Farther they are from the origin, more utility they represent. And the axis 1, good 1, and on the axis 2, quantity of good 2. Farther from the origin we would like to buy IC3, but it's not possible because we have, by maximizing, moving farther from origin, not enough money. Let's see the principle of budget line in the next slide. Let's introduce the budget line for the goods 1 and 2. The budget line, which represents the amount of money available to the customer. It is a descending slope line connecting the axes y and 2 for quantities of the goods. If I buy 10 pieces of good 1, I can't buy any piece of good 2. If I buy 10 pieces of good 2, I can no longer buy any piece of good 1 due to the budgetary constraints. I can also buy, for example, a combination of 5 pieces of good 1 and 6 pieces of good 2. All these points lie on my budget line. Let's add another property of indifference curves. There are infinitely many indifference curves. In the graph, you can only see 3 indifference curves as an example, but even between them lie countless amount of indifferent curves. Only the indifference curve that touches the budget line corresponds to the coordinates of the maximal achievable benefit. The tangent BL of the indifference curve indicates the optimal combination of goods 1 and 2. I mean their amounts, quantities. Consumer can choose IC1, it lies under the BL, but it's irrational because he has money for more. He can't choose IC3 because it lies above the budget line. The consumer has no money for it. Only the tangent BL of the indifference curve IC indicates the optimal combination of goods 1 and 2, where consumer maximizes his utility. This point has coordinates q1 and q2. These two coordinates represent the optimum 1 point, 2 coordinates. We are looking for a point where budget line is the tangent of one of infinitely many indifferent curves. Let's start with writing down the mathematical expression. Budget line means that the yield, abbreviated Y, characterized by the price P and the amount Q for goods 1 and 2 is higher than the farther budget line is from the origin. Simply said, more yield, more money in your pocket, more utility you can reach as a consumer. For a higher income, we could be, for example, at this point where the new budget line tangent would determine the new combination of Q1 and Q2. The budget line is the distribution of income over a combination of prices and quantities of goods 1 and 2. Prices of good 1 and quantity of good 1, price of good 2 and quantity of good 2. To express the indifference curve, the optimum is given by the quality the marginal utilities. There's a fraction, marginal utility 1 over marginal utility 2 of the second good. And this with respect to the relation of prices of goods 1 and 2, expressed by the fraction price of the first good over the price of the other good. For the price P1 10 euros, price P2 5 euros, we have a yield of 100 euros. Let's calculate the points Q1 max and Q2 max. Here the axis intersection points of the budget line. These are the maximum quantities of the goods represented in blue and red color in the graph. If you connect them, you become the budget line. That's why we need them. Let's start with the calculation. We substitute for the price P1 10 euros and the price P2 5 euros. You see where to substitute. We also know the Y. It is 100 euros. And we are searching for the points Q1 and Q2. That is the equation of our budget line. We will now express this part for a budget of 100 euros. What is the maximum quantity of the first good we can buy if we do not buy any piece of product 2? So for Q2 0, it is Q1 max, maximum quantity of the first good 10 pieces, 10 units. Or if we do not buy any quantity of product 1, what is the maximum quantity of product 2 if you have 100 euros in your pocket? So for quantity 10, it is quantity 2, maximum 20. We draw points 10 and 20 in the graph. We respect the blue color for product quantity 2, the red color for product quantity 1. We got these proportions. The total benefit, total utility, given by this expression, 6Q1 plus 2Q2 plus Q1 times Q2. The price of good 1 is 2 euros. The price of good 2 is 1 euro. Yield is 40 euros. Determine the optimal size of the consumer basket. To do this, to search for the optimal size of the consumer basket, you need this form of budget line equation. Y equals to P1 Q1 plus P2 Q2. We can use substitution. We know Y is 40 euros. Price of the first good is 2 euros. Price of the second good is 1 euro. We only don't know quantities Q1 and Q2. We know that marginal utility 1 over marginal utility 2 should be, in the optimum, in ordinalist theory, equal to ratio of prices of the first and second good. Now I need marginal utility 1. I can calculate it from here, from total utility expression, with the help of derivative of total utility according to quantity 1 and the same according to quantity 2 for mu2. Thus, a marginal utility 1 is a derivative of the total utility according to quantity 1. That is 6 if we derive according to Q1, then Q2 falls out of the second member of the sum, and Q2 remains of the third member of the sum. The same for the marginal utility of the second good. After derivation of total utility according to quantity 2, the result is 2 plus Q1. Let's have a simple system of equations now. So 40 equals to 2Q1 plus Q2 is derived from the prices 1 and prices 2. We also know marginal utility 1 over marginal utility 2 should equal to price 1 over price 2, which was 2 over 1, which is simplified as 2. I will substitute for this Q2, which I express here in the fraction. So Q2 is 40 minus 2Q1. And now the substitution of this expression here, the denominator of the fraction. 6 plus 40 minus 2Q1 over 2 plus Q1 equals to 2. I have to simplify this expression and multiply by the denominator. (46) minus 2Q1 equals to 4 plus 2Q1. Now all Q1s to the left and the rest numbers to the right. It means minus 4Q1 equals to minus 42, thus Q1 equals to 10.5. I also need the other coordinate, because now I just got Q1 with the help of substitution. I can write that Q2 is 40 minus 2 times 10.5, which means that q2 equals to 19. That's the other coordinate. Interpretation: if the consumer consumes 10.5 units of good 1 and 19 units of good 2, he is in the optimum. We draw 4 of an infinite number of IC curves. IC1 is not the optimal choice because I have 4 more units of goods. I can increase my utility. IC3 is not optimal because it lies above the line BL, so I have no money for the combinations of goods it represents. And IC2 is optimal because it touches the budget line, a point with coordinates 10.5 and 19 is the consumer's optimum in the ordinalist theory of utility. Evaluate the situation when total utility equals to 4q1 plus 6q2 plus q1 q2. The price of the first good equals to 2 euros and the price of the second good equals also to 2 euros. The yield is 26 euros. And we also know quantity of the first good is 8 pieces or units, and quantity of the other second good is 4 pieces or units. Is the consumer behaving rationally? Let's repeat the general equation for the yield. It's P1Q1 plus P2Q2. The general equation for optimum, mu1 over mu2 equals to price 1 over price 2. Now we can substitute all the numbers we know. For yield 26, price 1 2 euros and price 2 2 euros. So we have the concrete form of yield expression, and now marginal utility 1 is the derivative of total utility according to quantity of the first good. So we know from the above du expression it's 4 plus q2. And marginal utility 2 is the derivative of total utility according to quantity of the second good, q2, which is 6 plus q1. We can write now the fraction mu1 over mu2 equals to price 1, which is 2, over price 2, which is also 2. So I can simplify it equals to 1. From here, I express q2, which is 13 minus q1, and I substitute this to the fractions numerator. 4 plus 13 minus q1 . The denominator and the right side stays the same, but I want to simplify the fraction so that I multiply by the denominator. 17 minus q1 is 6 plus q1. From here to q1 is 11 and q1 is 5.5. Now let's take Q2 and calculate with the substitution 13 minus 5.5. Q2 is 7.5. Now I have both coordinates of the optimum in the first situation. This situation is the real optimum, but the given one is not. It's different from this. That's why the consumer is not behaving rationally. In the graph, we can easily see for quantity 1 and quantity of the second to Q2 and the budget line BL, which touches the axis in points 13 and 13. They are calculated as 26, which was the given yield divided by price 1 for Q1 axis is 13, and by price 2, which is also 2 and also 13. Now we calculated the point, which is the real optimum, 5.5 and 7.5. In this new example, we will find the coordinates of the optimum Q1, Q2 for total utility given by the expression 8Q1 plus 2Q2 plus Q1, Q2. We know that the yield is 22 euros, the first price is 3 euros, and the price of the other good is 1 euro. We also have the delta P1, so the change in price is minus 1 euro. Let's start searching with the budget line. We know that yield is 22, price 1 is 3, and price 2 is 1 euro. That's why I substitute to the budget line expression, and I express Q2, the quantity of the second good, is 22 minus 3Q1. Now, for indifference curve optimum, I know that I need marginal utility 1 over marginal utility 2, which is the derivative of total utility according to Q1 for marginal utility 1, which is 8 plus Q2, and for marginal utility 2, its derivative of total utility according to quantity of the second good, which is 2 plus Q1. Now I can make the fraction complete, 8 plus Q2 over 2 plus Q1, which is marginal utility 1 over marginal utility 2, and it equals to 3 because that's price 1 3 over price 2 1 simplified. Now I can substitute my Q2 in the numerator of the fraction, which equals to 3. It was the fraction of prices. I can simplify a bit, multiply it by denominator, and from here I can express quantity of the first good easily. Let's make it by heart. Quantity 1 is 4. I need the other coordinate for quantity of the second good, Q2, which is easy. I just substitute Q1 in this expression, 22 minus 3 times 4. By heart, quantity of the second good is 10 pieces or units. Now I have both coordinates of the optimum in the first situation. Let's go to the other one with delta P1 minus 1. For the new situation, yield is the same, 22. The first price is changed from 3. Delta P1 is minus 1, so 3 minus 1 is 2 times Q1 plus Q2, where price 2 is unchanged, stays 1. From here I easily express Q2 as 22 minus 2Q1, and the fraction M1 over M2 equals to price 1 over price 2. The right side changed to 2, the left side marginal utilities stay the same in our new situation, and I can substitute in the numerator for Q2. So 8 plus 22 minus 2Q1 over 2 plus Q1 equals to 2. Now I just simplify by multiplication. So multiply whole left side and right side of this equation by the denominator, and you get this. After simplification, Q1 by heart equals to 6.5. I just need the other coordinate Q2, which is after substitution 22 minus 2 times 6.5. And by heart, this is 9. I have both coordinates of the optimum in the new situation. Sketch indifference, curves, and budget lines for this situation. In the first situation, I see 1, indifference curve 1, met budget line 1 at a point 4 and 10. In the other situation, the green indifference curve 2 met the budget line 2 at the point 6.5 and 9. Also, we know the points where budget line 1 meets the axis Q1, calculated like yield 22 divided through price 1, 3, which is approximately 7.3. And 22 is the point when budget line 1 meets the axis Q2, calculated like y, the yield 22 divided through price 2, 1, which equals to 22. And the other point of BL2 when it meets the axis Q1 is calculated like yield 22 divided through price 1, 2, which equals to 11. Now derive the demand curve from the first good. Therefore, we denote indices 1. Draw the change in the price P1 and the effect of this change on the change in the quantity demanded Q1, where orange is the original price and quantity and the green is the new price and quantity. So we draw for price of the first good P1 and the quantity of the first good Q1 the demand curve, descending curve D1, where the original point coordinates were 3 euros and 4 pieces, and the new coordinates are 2 euros and 6.5 pieces. It means that it corresponds to the law of demand, because with the lower price, the change was minus 1. As you know, the delta P1 was minus 1 euro. The consumer buys more pieces of the good 1. Q1 changed from 4 to 6.5 units of the first good. Now we will determine numerically income and substitution effects for total utility Q 8Q1 plus 2Q2 plus Q1 Q2, where price 1 is 3 euros. Delta of the price 1 is minus 1 euro and price 2 is 1 and yield is 22. The income effect is given by this first expression for delta Q1, and the substitution effect is given by the second expression, minus A times P2 times delta P1 over 2 times P1N, that's for new price, and this means delta Q1, the change of the quantity. These two parts are income effect on the left income effect, and this part on the right is substitution effect. We've just shown how to calculate delta Q1 income and substitution effects, but there was also a change in quantity 2 in our example, the delta Q2. In this change, there will be just the substitution effect, just the price 1 was changed, and it's expressed like B over 2 times delta in the price 1 over P2. This whole expression represents a substitution effect. Let's explain the indices A and B because the rest is known. Let's express delta Q1 according to the expression on the right side. We'll start with the income effect. Minus Y is minus 22, it's for yield, and minus 1, I should multiply it by, is the delta P1 over 2 times P1N means new price of the first good, which is 2 because the original P1 was 3, and delta P1 is minus 1. 3 minus 1 is 2. And now the last part of our denominator is the price P1, old one, which was 3. So I will write times 3 in the denominator. Let's calculate the income effect part of delta Q1 now. This is 11 over 6 when I make simplification, and it equals to 1.84. That is the change in pieces, and I can call this income effect. That's just the first part of the change, Q1. I also have the other part, so-called substitution effect, which is calculated like A, which is this 8 times P2, price 2 is 1, times delta in P1, this change was minus 1, and in the denominator there is 2 times price 1 new, which is 2, times price 1 old, which is 3. After simplification, 2/3, or approximately 0.66. When I take now both income and substitution effects together, I will express the change of the quantity of the first good, the delta Q1, which is 1.84 plus 0.66. By heart, it's 2.5 pieces. Let's express the substitution effect for the quantity of the second good. So the delta Q2 equals B over 2 times delta P1 over P2. Only substitution effect because the change was only the price of the first good. You know B from here is 2. So we substitute this number to our expression. And we can write that 2 over 2 times delta P1 was minus 1 and over P2 price 2 was 1 minus 1 over 1. This is minus 2 over 2, which is minus 1 completely. So the quantity of the second good changed downwards about 1 piece. Minus 1 is the delta Q2. Specify the original and new consumer basket if you know total utility equals to 20Q1 plus 6Q2 plus Q1 Q2. We also know yield is 56 euros, price of the first good is 2 euros, price of the second good is 1 euro, and the delta so change in the yield is plus 16 euros. Now we would like to specify the original and new consumer baskets. We will have two different situations. The first with the original yield 56 equals to 2Q1, which is price 2 times Q1, plus price 2 times Q2 is 1 times Q2, simplified Q2 only. From here I can express Q2, which is 56 minus 2Q1, derive total utility to get marginal utility 1, derive this according to Q1, that is the marginal utility 1 equals to 20 plus Q2 over marginal utility 2, which is the derivative of this total utility according to Q2, and this equals to 6 plus Q1. This fraction mu1 over mu2 should be equal to price 1 over price 2, as you know. Price 1 is 2, price 2 is 1, so 2 over 1 is 2. Let's substitute Q2 in the denominator. 20 plus 56 minus 2Q1 over 6 plus Q1 equals to 2. 76 minus 2Q1, and now I multiply by the denominator. 12 plus 2Q1, all Q1s to the left and all numbers to the right. It's 64, and that's why Q1 is 16. Now I just have the first coordinate for the first situation. I need the second coordinate, Q2, for the first situation before changing the yield, which is 56 minus 2 times 16. By heart we can calculate Q2 as 24 pieces. coordinates 16 and 24 are the original optimum consumer basket. And now, after we calculated original optimal consumer basket's coordinates Q1, Q2, we calculate these coordinates for the change in the yield delta y plus 16 euros. I just add this 16 euros to 56, which I had originally, and I get 72 euros. 2Q1 plus Q2 stays the same because the prices were unchanged. Q2 from here is 72 minus 2Q1. Now I calculate mu1 over mu2. I have to ask myself, is it changed or can I write the same ones? Yes, Q2 is changed. So the substitution will be 72 minus 2Q1. The rest 6 plus Q1 stays the same. The prices were unchanged, so the 2 stays the same. From here I easily express Q1 at first by multiplication. (92 minus 2Q1 equals to 12 plus 2Q1). And from here, the first coordinate in the new changed optimum equals to 20. Till now I have all the blue values, original optimal consumer basket Q1 16, Q2 24, and the new optimal consumer basket was just calculated for the quantity 1. Quantity 2 is calculated by the substitution of Q1. 72 minus 2 times quantity 1. It means 72 minus 2 times 20, and it's 32. Now I have both coordinates for the new optimal consumer basket, 20 and 32, and I can easily calculate quantity 1 change. It's 20 minus 16, so plus 4 pieces of the first good, and also the change in quantity of the second good, delta Q2, which is 32, so new coordinate minus 24, so the old coordinate, which is 8. Let's sketch IC curves and budget lines for this situation. Q1 axis means the quantity of the first good, Q2 axis means the quantity of the second good. We know that BL1 is budget line for the first situation for the yield 56, and BL2 is the budget line for the second situation for the yield 56 plus 16 plus this delta y, which means 72 euros. Indifference curve 1, the yellow one, meets the budget line 1 at the point 1624, the original optimum, and for the new optimal consumer basket 20 and 32, there is the green indifference curve 2 at the point where it meets the tangent budget line 2. The points which we calculated are for budget line 1 yield 56 over price 1, 2, which is 28. Yield 56 over price 2, 1, which is 56. Yield 72 over price 2, 1, which is 72, and yield 72 over price 1, 2, which is 36. Let's sketch D curves now, derived from the IC curves and budget lines. For P1, price of the first good, and Q1, quantity of the first good, we have here the individual demand curve at the price 2 euros, originally 16 pieces, and newly for D stripe, new demand individual curve, 20 pieces. It means an increase in income leads to an increase in the quantity purchased. Delta, or change of quantity of the first good, Q1, is 20 minus 16. It is 4 units or pieces of the first good. And it means by unchanged price and increased yield level, the consumer buys 4 pieces more. And this is the change of the position of demand curve. It is moved to the right, and there is no change along the demand curve. This means we don't speak about luxurious or inferior good, but about normal good. Similarly, an increase in income by the second good leads to increase in the quantity purchase. Delta Q2 is 32 minus 24. It means 8 pieces more were bought in the second situation, where the price is unchanged and stays at the level 1 euro for a piece of this good. Also here was the shift of demand curve to the right. And that's why by unchanged price and changed yield, there was a positive change in quantity. We had to move the demand curve to the right. We can say it is not a luxurious good, it is not an inferior good, but it's a normal good in the case of the second good.
At the end, there is just to say subscribe and give me likes. See you soon!